All right, number 19. So this is this is page 61 through 76. Numbers 19 through 28. Number 19 says let f be the function given by f of x equals x cubed minus 6x squared, and the graph is concave up when x is. So if I give you the original function, concavity is determined by the sign of the second derivative. So we need to find the second derivative. So f prime of x is 3x squared minus 12x. F double prime of x is 6x minus 12. And we want to set the second derivative equal to 0 and solve for x, which I hope, without too much trouble, you can see x is 2. So onto a number line we go. This is an f double prime number line. F double prime is 6x minus 12. If x is 2, if I pick a number to the left of 2, say 0, 6 times 0 minus 12 is negative. And to the right of 0, say 3, 6 times 3 is 18. 18 minus 12 is 6. That's positive. So this says f is concave down on the interval negative infinity to 2, and f would be concave up on the interval 2 to infinity. So we're concave up when x is greater than 2. Choice A. Easy question. Very easy. All right, number 20 says g of x is x squared minus 3x plus 4, and f of x equals g prime of x. Then the integral from 1 to 3 of f of x dx equals. There's a few ways you could run through this. You can say, well, the integral from 1 to 3 of f of x dx, well, if f of x is g prime, okay, I could say, well, f of x is g prime, so this is the integral from 1 to 3 of g prime of x dx. There's one of two ways you could do this. I could say, well, g of x is x squared minus 3x plus 4, and physically go and find g prime, which is 2x minus 3. So now I'm integrating from 1 to 3 of 2x minus 3 dx. And then I needed to find an antiderivative. So the antiderivative of 2x is 2x squared over 2 minus 3x, evaluated from 1 to 3. The 2's cancel, by the way. So we really have x squared minus 3x. And just do this out. So we have 3 squared minus 3 times 3 minus parentheses 1 squared minus 3 times 1. So we get 3 squared is 9, minus 3 times 3 is 9, minus 1 minus 3. This becomes 0 minus negative 2, which is 2. 2 is choice C. There's another way to do this, by the way. If you thought of this integral, it doesn't really matter what antiderivative you choose. The integral from 1 to 3 of g prime of x dx is just g of 3 minus g of 1. There's another way to do it, probably a little harder, but you could have also thought of it this way. G of 3, and this is by the fundamental theorem of calculus, because the antiderivative of g prime, you evaluate g at 3 minus g at 1. So g at 3 would be 3 squared minus 3 times 3 plus 4, minus, and you'll see how this works, it's going to come out to the same thing, 3 squared minus 3 times 1 plus 4. Oh, sorry, 1 squared. Sorry, 1 squared minus 3 times 1 plus 4. 3 squared is 9, minus 3 times 3 is 9, plus 4, minus 1 minus 3 is negative 2. Negative 2 plus 4 is positive 2. What basically happens is these 4's are going to cancel out with the arithmetic here. If these go away, 4 minus 2 is 2. So either way works. I seem to prefer the left-hand side, but the right-hand side is just as good. Number 20 says the graph of f prime, the derivative, is shown from 0 to 10. The areas of the regions between the graph of f prime and the x-axis are 26 and 4 respectively. It says if f of 0 is 2, what is the maximum value of f on the closed interval 0 to 10? Well, if we think for a minute, this is f prime. We would like to find a maximum of f. So I turn to the derivative, and I want to make a little sign chart here for the derivative. My f prime is positive till I get to this number. Negative till I get to here, because we're looking for the feature of this graph of f prime being above or below the x-axis. And then we're above till 10. So if you think about what that means, actually I want to take this chart and just move it down. I want to move it down here. Okay. What this means is that f is increasing till this point, decreasing and then increasing. So where could I have my maximums? Well, I could have my maximums at this asterisk here or at 10. Well, which is it? They told me f of 0 was 2. And think about it. If I have f prime is like the rate of change. Okay? When I integrate f prime, the rate of change, I go back to the original function. And we've done this a lot. F of x, the original function, is your starting value 2 plus the integral from 0 to wherever you'd like to go, x, of f prime of t dt. This is kind of like the gallons question we'll work on in class, where they say, okay, the tank has 125 gallons, right? And your rate, you're pumping gallons in or out at a rate of whatever. You add the integral on to the original, you add this integral on to the original amount, and that will give you the amount of gallons that you have. It's the same concept, except there's no context to it. So now the question becomes, well, what is the maximum? Well, there's two candidates. There's this start-off point here and 10. So f of the start-off point is 2 plus the integral from 0 to the start-off point of f prime of t dt. The integral is the area underneath the curve. So this is just 2 plus, well, the area underneath the curve from 0 to the start-off point is 20, which is 22. We also should compare f at 10, which would be 2 plus the integral from 0 to 10 of f prime of t dt, which is 2 plus 20 minus 6, because the 6 is below the x-axis. Remember, integrals are about net signed area. So if you're underneath the x-axis, the integral is negative, plus 4. And so we get 2 plus 20 is 22, minus 6 is 16, minus 6 is 14, plus 4 is 18. 22 is the winner. So 22 is the maximum. Now, you could have done this question in a lot less time. I'm sure some of you are probably like, okay, well, I'm accumulating an area of 20 to here. I'm going down 6 and up 4. The 20 is way bigger, so my maximum has to be 2 plus 20. Notice they do include 20 as a choice here. It's not 20, it's 22, because I already had, say, 2 gallons in the tank. All right, number 22. We have f prime of x is this factored form of the derivative. Then it says f has which of the following relative extrema. The question's talking about mins or maxes of f. So we turn to f prime, which we already have. I need to set this thing equal to 0. Which I hope you see, these are linear factors, so I can set them each equal to 0. And I get 2, 3, and 4. Those numbers have to go on my number line for f prime. 2, 3, 4. And I pick a point, say, to the left of 2. So I want to pick 1. 1 minus 2 is a negative. 1 minus 3 is a negative, but square anything, it's a positive. So I'm actually going to make this positive and circle it. It's always positive. X minus 4 cubed, if x is 1, 1 minus 4 is negative 3, cubed is a negative. A negative times a positive times a negative is a negative. Is a positive. My bad. Is a positive. Picking a number between 2 and 3, I'll pick 2.5. 2.5 minus 2 now becomes a positive. The x minus 3 squared term, or factor rather, is always positive. And 2.5 minus 4 is negative. Cube it, it's negative. A positive times a negative is a negative. Onward to 3 to 4. 3.5 minus 2 is still positive. This factor is still positive. And 3.5 minus 4 is negative. Cube it, a negative, it's negative. Positive times a negative is a negative. And then past 4, 4 plus 2 is positive. 4 minus 2 is positive. 4 minus 3 is, well, anything squared is always positive. And then say 5, because I want to go past the 4. 5 minus 4 is 1 cubed is positive, so now we're positive on that interval. So here's our number line, which means f is increasing, decreasing, still decreasing, and then increasing. So a relative max at 2, I agree with. A relative min at 3, I do not agree with, because we're decreasing through 3. So what's happening is, even though the derivative is equal to 0, the graph doesn't go back up, it goes down. And a relative max at 4, I don't agree. We have a relative min at 4. 1 only is the choice. If you mess up one of these intervals, you're going to mess up the choices. So this is definitely a good question to handle. All right, number 23 says the graph of the even function y equals f of x consists of 4 line segments above. Which of the following statements about f is false? This is a hard question because it requires us to kind of look at some different scenarios here. The limit as x approaches 0 of f of x minus f of 0 is equal to 0. Well, let's see. If the limit as x approaches 0 of f of x minus, what is f of 0? Well, f of 0 is just 0. So this first choice is really asking us, what's the limit as x approaches 0 of f of x? Well, limits we're thinking of, coming from both sides closer to 0. So our shutter method, if you will. If I'm coming from the left or to the right, this is indeed 0. I'm approaching 0 from both sides. So I think this is true. No good. Part B says the limit as x approaches 0 of f of x minus f of 0 over x equals 0. This limit you might recognize if I write it instead of an x as an h. So instead of putting an x in there, I put an h. And I also put in an x being 0 plus h. This is actually the derivative. Okay? This is f prime at 0. F prime at 0, if we look, the function has a corner. So this does not exist. So this is actually our false choice. Okay? Now I want to look at a few of others of these. Okay? C says the limit as x goes to 0 of f of x minus f of negative x over 2x, does that equal 0? They said the function was even. And I know some of you don't have a lot of experience with even functions. But what even functions are functions that are symmetric about the y-axis. So if you notice, if I'm at 2, f of 2 is the same thing as f of negative 2. F of, say, 6 is the same thing as f of negative 6. So f of x and f of negative x are actually identical. So I can go here and say, see, limit as x equals to 0. This is of f of x minus f of x over 2x, which is 0. Let's see. F of x minus f of x is 0. So the limit as x goes to 0, the limit as x goes to 0 of 0 over 2x. 0 divided by 2x is always 0 no matter what x is doing. So this is actually a true statement. D. D is interesting. If I think about what this is, f of x minus f of 2 over x minus 2. This is the slope. And it's a slope centered around the number 2. And now I'm taking the limit as x goes to 2. So if you think about what's happening, I'm taking slopes of secant lines and applying a limit. So now it becomes the slope of a tangent line, or it becomes the derivative. This is actually another form of the derivative. So this is actually f prime at 2, because it's the limit of a slope, so it becomes a derivative. Is that equal to 1? Well, let's see. At 2, it looks like the slope is indeed 1 over 1, up 1 over 1. So I agree with this. This is true. And Here's another very similar limit, except it's at 3. This is the derivative at 3, and it says does not exist. Well, if I look at 3, there's a corner there, so this limit does not exist. That's true. So the answer is choice B. That's a hard question. I have a feeling a lot of people would have gotten that wrong, just in general, taking the test. All right, number 24. The radius of a circle is increasing. At a certain instant, the rate of increase in the area of the circle is equal to twice the rate of increase in its circumference. It says, what is the radius of the circle at that instant? Well, we're talking about the quantities of area and radius. So the formula that relates area and radius is A equals pi r squared. Now we want to get rates involved. It says the rate of increase of the area of the circle is equal to twice the rate of the increase of its circumference. The way to get rates involved in this is to take the derivative with respect to time on both sides. We did this. This is called related rates. We haven't done this in a while, though. The derivative with respect to time of area is dA over dt. That's the rate at which the area is changing over time. Equals pi is a constant, so it comes along. The derivative of r squared is 2r times r is a function of time, so we're using the chain rule, and we're going to get dr over dt. So it says, at a certain instant, the rate of increase in the area of the circle. So if we wanted to see this, the rate of increase in the area of the circle is the quantity, is the quantity dA over dt. And it says this is equal to twice the rate of increase in its circumference. Interesting. It's equal to twice the rate of increase of the circumference. Circumference gets involved now. Circumference, if you recall, is 2 pi r. So circumference is 2 pi r. So if I want the rate of increase in the circumference, I now have to take the derivative with respect to time on both sides of this. So this is a little tricky of a question. dc over dt equals 2 pi dr over dt. The rate increase of the area is equal to 2 pi, I got that wrong, sorry. The rate of increase of the circumference is 2 pi dr dt. So the area's increase is twice the rate of the increase in the circumference. But if you take a look right here, I can find 2 pi dr dt in the formula for dA dt. So if I look at this, 2 pi and lumped it together with dr dt, this all really is dc over dt. So we have dA over dt is dc over dt times just the radius. So if I want the area's rate of change to be twice the rate of the circumference's rate of change, or twice, rather, sorry, let me say that again. If I want the area's rate of change to be twice the amount of the circumference's rate of change, all the circumference's rate of change in comparison to the area is multiplied by r. So if I want this number to be twice this, the r would have to be 2. Tough question, no doubt. And you see they get a little harder and a little more thoughtful as we go into these. That's not one I would expect everybody to get. All right, number 25. This one is very straightforward. It's an old implicit diff question. Got to get it right, especially if you spend the time on it. You must get it right, because what happens is if you don't get it right, you're spending time for naught. So you got to be very careful when you do this. So number 25 says, if I have x squared y minus 3x equals y cubed minus 3, then at the point negative 1, 2 dy dx equals. So I have x squared y minus 3x equals y cubed minus 3. And I would like to differentiate both sides with respect to x. So now, this is just got to be very careful. I have x squared times y. So that's going to require a product rule, which I'll do on the side here. I have my x squared and y. The derivative of x squared is 2x. The derivative of y with respect to x is dy over dx. So now we have, if I put this together, if I crisscross and put it together, I have x squared dy over dx plus 2xy minus the derivative of 3x is 3 equals the derivative of y cubed. We're using the chain rule because it's stuff cubed. The derivative of y cubed is 3y squared times the derivative of y with respect to x. And the 3 gets thrown away. Now what we have to do is move all our dy dx terms to one side and all of our non-dy dx's to the other. The easiest way to accomplish that is to subtract the x squared dy dx from both sides. So I would get 2xy minus 3 equals 3y squared dy dx minus x squared dy over dx. And now I can factor out the dy over dx, which is what I'd like to solve for. So one more step algebraically, divide both sides by 3y squared minus x squared. So dy over dx equals 2xy minus 3 over 3y squared minus x squared. And we need to evaluate this derivative at the point -1, 2. So dy dx evaluated at the point -1, 2 is 2 times -1 times 2 minus 3 over 3 times -1 squared minus 2 squared. So dy dx at the point -1, 2. 2 times -1 times 2 is -4 minus 3 over -1 squared is 1 times 3 is 3. 2 squared is 4. Whoops. 2 squared is 4. So now I get -4 minus 3 is -7 over 3 minus 4 is -1. And this is equal to +7. And that seems like a lot of work, but I was talking through each step pretty carefully. And just +7 was the answer, choice E. I was talking through every step carefully. I'm sure that you could have done that faster if you weren't. All right, 26. For x greater than 0, f is a function such that f prime of x is ln of x over x, and f double prime of x is 1 minus ln of x over x squared. It says which of the following is true. And they're talking about f increasing or decreasing or being concave up and concave down. So f prime tells us if f is increasing or decreasing. So I want to set f prime equal to 0. If ln of x over x is equal to 0, multiply both sides by x. So ln of x is equal to 0, which never happens. There's no power of e that gives you 0. So this has no solutions. But we also have to keep in mind that the derivative sorry, that's not correct. Sorry about that. I don't know what I was thinking. So ln of x over x equals 0. If you cross multiply, we get ln of x equals 0. ln means log base e of x equals 0, which says e to the 0 equals x, so x is 1. And this derivative is not defined at 0 or past 0, so that's also a critical value, but notice the domain of the function already excludes that. So we can now draw on a number line a 1. This is for f prime. Actually, you know what? Just to space this out, I'm going to do this. I'm going to do it nice and neat over here. 0 I don't care about. At 1, let's see. So my derivative is ln of x over x. So I'm making a number line for the derivative. ln of x over x, I'll pick a number to the, say to the left. ln of anything less than 1 is less than 0. So if I have something negative divided by any number between 0 and 1 is positive, a negative divided by a positive is a negative. To the right of 1, say I have the ln of e. The natural log of e is 1, positive, and x is positive, so we're positive. Now we need to do the same type of thing for f double prime, which was 1 minus x ln of x over x squared. So f double prime of x equals 1 minus ln of x over x squared, and find out when this thing is equal to 0. So cross multiplying again, we get 1 minus ln of x is equal to 0. And so we're going to subtract 1 from both sides. So we get negative natural log of x is negative 1. ln of x is 1. So e to the 1 equals x, or x is just e. So for my second derivative, number line, I have f double prime. F double prime is 1 minus ln of x over x. My critical value is e. E is to the right of 1, so I want to line this up nicely. If I plug in a number, say, to the left of e, like, for example, the number 1, 1 minus ln of 1, 1 minus ln of 1 is 0, so 1 minus 0 is 1, divided by 1 is positive. And then if I go to the right of e, say e squared, if I plugged in e squared in here, 1 minus ln of e squared, the ln of e squared is 2. 1 minus 2 is negative 1, divided by e squared, which is a positive. If I have a negative divided by a positive, I get a negative. So here's my number line. Okay, and now we can look at the choices. The function decreases when x is less than 1 and increases after that. The function is concave up for x less than e and concave down for x is greater than e. So we just have to match up the correct choice. So I agree with, so if you kind of eliminate, you could even eliminate choices on the, just based off the blue, even if you didn't want to do the red. Even if you want to do the second derivative, you could eliminate choices here. So if I had f is decreasing for x greater than 1, well, that's not true. F increases. And then f is not increasing between 0 and e. So all those are gone just by the increasing part, not even addressing the concavity. So now we're just asking whether the function is concave up or concave down for x greater than e, and it's concave down for x greater than e. So I say you could eliminate 3 choices and not even, have a 1 out of 2 shot at getting that right. Number 27 says, if f is the function given by f of x is the integral from 4 to 2x of radical t squared minus t dt, then f prime of 2 is. If we remember, if I have a function defined by an integral, and I go and differentiate it, those two things are opposites. But just remember something. If I have a function like this, say g of x is the integral of 3 to x of, I'm making this up, sine of t squared dt, I can just replace the t with the x, and this would just be sine of x squared. So long as this is just an x, and the lower limit of integration is a constant. However, I don't have that in this situation. What I do have, however, is a 2x. So it's kind of like the chain rule. Instead of having an x up here, I have stuff. So while I'm still going to replace the t with the 2x, I have to remember to multiply by the derivative of 2x, which is 2. So I'm now asking for f prime at 2. So I have the square root of 2 times 2 squared minus 2 times the 2 that they're asking me to plug in, times the 2, which is outside the radical. I'll even put it in its own parentheses, that we got from the chain rule application here. So let's see. 2 times 2 is 4 squared is 16 minus 4 is radical 12 times 2. So I look like I have 2 square root of 12. Notice if you forgot this 2 from the chain rule, there's choice D ready to trip you up. And number 28. If y is equal to inverse sine of 5x, then dy dx is. A good time to review your inverse trig derivatives. You have to know inverse sine derivative, which is 1 over the square root of 1 minus x squared. Cosine inverse is not typically tested that I've seen, but it's just the negative version of this, which you can kind of remind yourself the derivative of sine is, is cosine. The derivative of cosine is a negative sign, so it kind of works the same way. You put a negative sign. And the derivative of inverse tangent is 1 over 1 plus x squared. So now we want the derivative of sine inverse of stuff. So the derivative of sine inverse of stuff equals 1 over the square root of 1 minus the stuff squared. The stuff is 5x. But again, we were using a chain rule, so we have to remember to multiply by the derivative of the stuff, which is 5. So we get 5 over the square root of 1 minus 5x quantity squared is 25x squared. And that's choice E. So notice, the choices kind of give you a reminder of what the derivative should be. Notice this one looking like an inverse tangent, except they forgot the 5. This one looks like inverse tangent's derivative done correctly. This one looks like inverse cosine's derivative done correctly. This one looks like inverse cosine's derivative not done with the chain rule. So they're going to get you on the other stuff that you may have forgotten. I don't see this as a hard problem. I see this as something you really just have to have memorized and know off the top of your head. And I'm sorry this one went a little longer, but these were a little harder.